Okay, let's look at question 25. Okay, so you started with, over here you started with H2SO3. Alright, you started H2SO3. So H2SO3 will react, maybe I should write here, H2SO3 will react with OH minus, right, to form HSO3 minus plus water. So over here, when you reach the first equivalence point, you have HSO3 minus. So HSO3 minus will react with OH minus again to form SO3 2 minus plus water. So this point is SO3 2 minus. All right. Okay, so let's look at the question. Explain the meaning of the term Bronsted acid. Okay, what's a Bronsted acid? A Bronsted acid, a weak Bronsted acid. Okay, a weak Bronsted acid. Okay, so how to explain the word weak? A weak is a weak Bronsted is one that dissociates partially to donate H plus ions. Alright, so Bronsted acid is actually a proton donor, so you say donate H plus ions. Okay, so that. Okay, let's see how you do B. H2 H2SO3 will dissociate to give you H plus and HSO3 minus. Alright, so the initial concentration, okay, I put initial in terms of moles per dm cube. Okay, the initial concentration of this is 0.2, as you can see, 0.2. Alright, since they told you the pH, right, the pH at point A is 1.44, which imply H plus concentration, you work it out, is equals to 10 to the power minus 1.44. Alright, so in fact ICE, so in fact you know what's the H plus concentration, which is 10 to the power minus 1.44. Can you see that? So which means here will be plus 10 to the power minus 1.44 plus 10 to the power minus 1.44, 10 to the power minus 1.44. Yeah, here will be minus 10 to the power 1.44, 0.2 minus 10 to the power minus 1.44. Can you see that? Okay, so now you can actually calculate Ka quickly. So Ka is equals to 10 to the power minus 1.44 square. Okay, we are using these values here. All right, at equilibrium. All right, so plug it in over 0.2 minus 10 to the power minus 1.44. Can you see that? So you work it out, you get the value of 8.05 times 10 to the power of minus 3. Okay, moles per dm cube. Right, so that's how it's done. Okay, let's look at the next question. Explain with the by writing two equations, show how the solution at point B act as a buffer. So let's look at point B. Right, point B is over here. So what is present at point B? Point B, you would have equal amount of HSO3 minus as well as SO3 2 minus. All right, so they say write two equations, show how the solution at B acts as a buffer when the small amount of acid or base is added. So maybe I just do it over here. So this is for question C. So when a small amount of H plus is added, it reacts with SO3 2 minus, right, which is actually a weak base, to form HSO3 minus. If you add OH minus will react with HSO3 minus to form SO3 2 minus plus water. Okay, so this is the equation we are looking at. Right, so that's how a buffer works. You add H plus or you add OH minus, the buffer will remove the H plus or the OH minus. Last question, which is D. With the help of an equation, why pH at point C is not equal to 7. Right, Point C, actually you only have SO3 2 minus. In fact, SO3 2 minus is a weak base. Alright, so which means you have to write SO3 2 minus will dissociate in water to give you HSO3 minus. Alright, because it's a base, it will accept a proton and then it produces OH minus. Alright, so producing the OH minus will cause the solution to be basic. So you have to say that it undergoes, okay, if you have to explain, you say SO3 2 minus is a weak base and undergoes hydrolysis in water to produce OH minus. That's it.